let's look at number 7 together. So 7 also is looking at half-life. The Tylenol also has a half-life, and its decay rate is negative 0.231. So let's determine the half-life of Tylenol. How long or how many hours does it take for it to get to half of its initial dosage? So here we are going to write the model again. And this time we have negative 0.231 T. And we know that A is going to be half the original amount, A initial. I'm just going to put 1. If you take 1 tablet, I'm trying to see when it becomes half a tablet. So E, negative 0.231 T. We're trying to find T. That's our goal, half-life, like how long it'll take. So now, of course, we're going to do ln of both sides, ln of half, with ln of E, negative 0.231 T. ln of E cancels. We have ln of half equals negative 0.231 T. Divide both sides by negative 0.231, negative 0.231, canceling out. Get T is equal to ln of half. Let's put that in. Divided by negative 0.231. We have around 3 hours. So 3 hours is the half-life of Tylenol. That's the amount of time it takes to have 1 pill. If you take 1 pill, to take that down to half a pill. So that's why it says like you have to keep taking it every 4 to 6 hours to maintain that concentration. Right, what is the last topic? It's Newton's law of cooling. So Newton's law of cooling uses the exponential decay here. Is over a period of time, a hot object cools down to match the temperature of the surrounding air. So Newton came up with this formula. T is equal to C plus parentheses T initial minus C parentheses E to the negative KT power. This is also used in forensic science to estimate the time of death, to compare like the temperature of the body. T is the time it takes for an object to cool from temperature, the initial temperature, to the temperature that it's at. And C is the surrounding air temperature. So there's like 3 temperature values that are going on. So let's look at the last problem together. So instead of doing like a dead body example, we'll just do a nice example. One of my favorite things to eat, a baked potato. So let's say we baked the potato in the oven, and when we removed it, it was at 194 degrees and was left in a room that has a temperature of 72 degrees. So after 30 minutes, the temperature of the potato was 162 degrees Fahrenheit. Based on that, let's calculate then what would be the temperature of the potato after 45 minutes. So here's Newton's law of cooling again, where T was the time it takes for an object to cool. So for this, we have to solve for K, like we have to come up with the model here. So what we need to do is first, we need to get K. So let's determine all the different things. So here T is like the final temperature of the potato. And so here T at, let's see, 30 minutes. So this is T at 30 minutes. It's 162 degrees Fahrenheit. C, the surrounding temperature is 72 degrees Fahrenheit. The initial temperature of the potato when we first took it out is 194 degrees Fahrenheit. And the time that it took the potato to cool from 194 to 162 was 30 minutes. And we don't know K, so that's what we're trying to find. So let's set this up. 162 equals 72 plus T initial 194 minus 72 E negative K times 30. Simplify as much as possible. 162 equals 72 plus 194 minus 72 is 122 e to negative 30k. So here, what we are going to do now, a lot of students think we need to add here 72 and 122 together. You can't do that because this is like, it's like adding then 72 plus 122x. You can't combine them, right? They're not like terms. So what we need to do first is we need to get e isolated. So we're going to subtract 72 both sides. And what that does is now 162 minus 72 is going to give us 90 equals 122e negative 30k. And now we're going to divide both sides by 122. So it becomes like the problem that we've done so far, 90 over 122. The e is isolated to negative 30k. Now we take the ln of both sides, and we're almost done because ln cancels e, where ln of e is just 1. And now ln of 90 over 122 is equal to negative 30k. Almost done, isolating k, divide by negative 30. And so let's calculate k. ln of 90 over 122 divided by negative 30. K is going to be 0. Let's do 4 decimal places again. 0101. So this potato, the cooling of the potato has a decay rate of 0.0101. Okay, so I think I need more space to write the equation down. So we didn't answer the question yet because it's asking what is the temperature of the potato after 45 minutes. So now I'm going to rewrite this equation as T equals C plus T initial. Actually, we can even just plug stuff in. So we're trying to find the T, and the surrounding temperature is 72 degrees, plus T initial is still the same. It's 194 minus 72, so we know that's 122. E to the negative 0.0101 T. Okay, so we just need to plug in 45 minutes into in for T. So let me just erase this part so I can do that. And so we get T is equal to, plug in 45 in for T, times 45. I think I try to squeeze in there, but it's kind of hard to see. Let me just write that better. Okay, T equals 72 plus 122e negative 0.0101 times 45 minutes. So we have 72 plus 122, raise it to e negative 0.0101 times 45. So we're expecting a cooler temperature, right below 162. And so it is cooler, so it's around 149. Let's do like 1 decimal place, so 149.4 degrees Fahrenheit. Okay, so that should help you with the homework problems for this week. As always, feel free to reach out